a 700-year-old sword can still kill today. Your modern tools won't survive 30 years. We believe technology makes materials better, but medieval steel was designed to last generations. Modern tools are designed to be replaced. That's not an accident. Look at your kitchen knives, your shovel, your wrench. They will bend, chip, or snap long before a medieval blade ever would. This is about what's in your garage right now. The screwdriver you bought 3 years ago that's already twisting at the tip. The garden shears that no longer close cleanly. The hammer handle that's starting to crack. Medieval tools from the 1300s are still functional. Yours won't make it to 2050. Modern steel looks perfect, factory polished, machine cut, identical from piece to piece. But strength isn't surface level, and uniformity is not the same as durability. When you hold a new tool, the weight feels right, the edges are sharp, the chrome gleams under store lighting. Everything signals quality, but that signal is aesthetic, not structural. Uniform steel feels safe. It feels controlled, like someone calculated every variable and eliminated every flaw. But uniformity is often weakness, because steel isn't just metal. It's a negotiation between carbon and iron, between hardness and flexibility, between what breaks clean and what bends forever. Medieval blacksmiths understood this, not through chemistry, through consequence. If your sword snapped in battle, you died. If your plow broke mid-season, your family starved. Failure had immediate weight, so steel carried that weight in its design. Modern steel doesn't carry that weight anymore, because failure has been delayed, externalized, spread across replacement cycles and warranties, and the assumption that you'll buy another one. Let's talk about what medieval steel actually was, because the popular image is wrong. Medieval steel wasn't primitive. It wasn't just hitting hot metal until it looked like a sword. It was a multi-stage process of intentional imbalance. The technique is called pattern welding. You take strips of iron with different carbon contents, some harder, some softer. You heat them, twist them, fold them, hammer them flat. Repeat. What you're creating isn't uniformity. You're creating a lattice of contradictions. Hard steel that resists deformation. Soft steel that absorbs impact. Layered together so the blade doesn't choose between strength and flexibility. It has both. In alternating microstructures, this is why medieval blades have that distinctive wavy pattern on the surface. It's not decoration. It's evidence. Evidence that the steel isn't homogeneous, that it was built in layers, that it contains internal complexity. The blacksmith didn't measure carbon content with instruments. He learned to read the metal, the color it turned in the forge, the sound it made under the hammer, the way sparks flew when it was ground. He knew that steel from a marsh had different properties than steel smelted from ore. He knew that quenching in oil gave a different hardness than quenching in water. He knew that the spine of a sword needed to be softer than the edge. So he didn't make a sword. He made a negotiated object, one that balanced contradictions. And here's the critical part. Medieval steel wasn't perfect. It had inclusions, impurities, microfractures. But those flaws were distributed. They didn't run through the entire structure. If a flaw caused a crack, the crack would hit a softer layer and stop. Modern engineers call this crack arrest. Medieval blacksmiths called it good steel because the weapon didn't shatter. It degraded slowly, visibly. You could see a chip forming. You could feel a bend developing. And you could repair it, rework it, before it failed completely. The steel wasn't designed to last forever without maintenance. It was designed to communicate its condition, to show you where it was weakening, so you could intervene. Medieval steel wasn't perfect. It was intentional, and that intention was survival. But medieval people avoided one type of steel. They knew it failed silently. There are documented cases from the 14th and 15th centuries, swords that looked flawless, sharp, balanced, strong in every test, but they came from a specific smelting process, one that removed too many impurities. That made the steel too uniform, and those swords would snap, not from weakness, from brittleness, from a lack of internal variation. The blade would hold through dozens of strikes and then fracture suddenly, catastrophically, with no warning, no visible crack, no bending. Medieval smiths learned to distrust this steel. They called it cold short or over-refined. They knew that purity wasn't the goal. Complexity was. Because a weapon that breaks without warning is worse than a weak weapon. A weak weapon bends. You see it failing. You adapt. A brittle weapon feels strong until the moment it kills you. And what's unsettling is this. That over-refined steel, that brittle, too uniform, failure-prone material, that's what most modern tools are made from. Mass-produced steel doesn't break loudly, it weakens quietly. Let me be clear, modern metallurgy is extraordinary. We can control carbon content to 0.1%. We can engineer crystal structures at the molecular level. We can produce steel that's stronger, lighter, and more consistent than anything a medieval blacksmith could imagine. But strength and longevity are not the same thing, and consistency is not the same as resilience. Here's what happens in a modern steel mill. Iron ore is smelted in blast furnaces. Carbon is added in precise ratios. The molten steel is poured into continuous casting machines, cooled rapidly, rolled into sheets or bars, heat treated in controlled atmospheres, quenched, tempered, cut, finished. Every step is optimized, not for longevity, for cost. The steel that goes into your hardware store tools is usually a grade called mild steel or low-carbon steel. It's cheap, workable, easy to machine, and it has just enough carbon to hold an edge, briefly. But it doesn't have the layered complexity of medieval steel. It doesn't have soft zones to arrest cracks. It doesn't have hard zones to resist deformation. It's uniform. And when it fails, the failure spreads evenly, invisibly. You don't your wrench weakening. You don't feel your shovel losing its temper. The molecular bonds are quietly rearranging under stress. Dislocations are forming in the crystal lattice. The edge is rolling microscopically with every impact. Not weak today, weaker every year. And then there's the heat treatment. Medieval blacksmiths would spend hours, sometimes days, heating and cooling a blade, testing it, adjusting. Modern tools are heat treated in minutes, in industrial ovens with conveyor belts. The steel reaches the target temperature, stays there briefly, then gets quenched in automated baths. It's consistent, but it's not thorough. The surface hardens, the core remains softer, and the transition between those zones is a line of vulnerability, a place where internal stress concentrates, where cracks begin. Medieval smiths avoided this by using lower temperatures and longer cycles. Modern factories avoid it by not caring. Because here's the reality. If your screwdriver lasts 15 years instead of 50, you'll buy 3 more in your lifetime. If it lasted 50 years, you'd buy 1. Planned obsolescence isn't a conspiracy, it's a business model. And it's baked into the steel itself, not through sabotage, through optimization, through the removal of unnecessary durability. The steel isn't poisoned, it's just not given what it needs to last. Slightly less carbon than ideal, slightly faster cooling than optimal, slightly thinner cross-sections than necessary. Each compromise saves a few cents, and each compromise costs you a decade. Steel isn't worse today. The intention behind it is. Let me say that again. Modern steel as a material is not inferior. We can create alloys that medieval blacksmiths couldn't dream of. Tool steel that holds an edge under industrial stress. Spring steel that flexes 10,000 times without fatiguing. But those steels cost more, and they're used in applications where failure has immediate, visible cost. Surgical tools, aerospace components, industrial cutting blades, military equipment. Your kitchen knife doesn't get that steel. Your garden tools don't get that care. Because your failure is private, it doesn't cost the manufacturer anything. When a medieval plow broke, the blacksmith's reputation died with it. The village knew who made it. The family who starved because of it knew who to blame. Failure was local, personal. When your modern drill bit snaps, you throw it away. Maybe you buy a different brand. The manufacturer never knows. You never meet the engineer who chose the cheaper alloy. Failure is distant, diffused, acceptable. This is why medieval steel feels superior. Not because it was technically better, but because the person who made it had to live with the consequences. If medieval steel was so good, why did we abandon it? The answer isn't technical, it's economic. A medieval sword took weeks to forge. One blacksmith, one apprentice, working full days, heating, folding, hammering, testing, adjusting, refining. The labor cost was enormous. But a sword was also a lifetime investment. You commissioned one, you maintained it, you passed it down. Your grandson would carry the same blade. When industrialization arrived, the goal changed. Not make one perfect thing, but make 10,000 acceptable things. Quickly, cheaply, consistently. Medieval steel wasn't advanced. It was honest. It showed its flaws. It communicated its condition. It failed in ways you could see coming. Modern steel is technically superior, stronger, more consistent, more precisely engineered, but it hides its weaknesses. It fails silently. It prioritizes profit over permanence. Neither is perfect, but one was made in a world where failure had weight, where tools were investments, where durability was survival, and the other was made in a world where failure is just a reason to buy again. A 700-year-old sword can still kill today. Your modern tools won't survive 30 years. That's not about the past being better. It's about what we've chosen to value and what we've chosen to accept.